All right, so last week we discussed abiogenesis, also known as what? Huh?
What was that for you guys?
No.
Abiogenesis?
Also known as what? Spontaneous generation. Very good. Reagan. Good job. All right. We also saw assumptions and deceptions, like the paleontologist who admitted to not having the transitional forms and the missing links, things like that. Okay, so realize there's a lot of assumptions and deceptions when we talk about evolution. You've got to be aware of those and look for those, because they won't say you're getting ready to be deceived. You know, they'll tell you things, so you got to be paying attention to know when they're doing that and when they're not. Okay. And then what science shows, things like the Cambrian explosion, we talked about that, and how the Bible describes this very well, like Genesis 1:24, okay? So we talked about that. We can see that in science, okay? Then we talked a little bit about the history of evolution and how it gave the mentality that people are expendable, and how that led to different worldviews. What were some of them that we mentioned? Anybody know? Worldviews from evolution, what that stemmed from and what they kind of led to.
Nazism?
That's one of them. Kind of along the same lines. What else?
Communism.
Oh, very good. Who said that over here? Good job. Good job. You were sorry. In your mind, you were ready for it. All right, so, and it led to things like, this leads to things what we saw in 1959, the push for evolution, and how in parallel we saw things spike. We saw all the different charts that showed that, like STDs, up 385%, like crime up 995%, teen suicide rates skyrocketed. We saw illegal drug use skyrocket 6,000%, child abuse skyrocket 2,300%, all in parallel with the evolution push and how those words increased in the textbooks by, who was the president at the time that pushed for that? Dwight Eisenhower. Yeah, baby. And so basically we learned that when you're taught that you're nothing more than an animal, well, we reap what we sow. And that's why these things all skyrocketed along with the push. Then we looked at the Stanley Miller experiment and the many, many flaws it has. And it has a lot of flaws. Anybody know what one of the biggest one was we ended up with? Any of the flaws at all? Anybody? Yeah, he put in exactly the elements that he knew were going to produce amino acids. Very good. But we also learned life cannot evolve with oxygen, and life cannot evolve without oxygen. So what was the solution? It didn't evolve. Very good. You can share it if you want to.
All right.
You're scoring right here. So the chamber that Miller had, what he actually produced was what was poisonous to life. Wasn't good for life at all. And lightning kills life as well. Okay. But we often hear about how the earth, the strata, or fossils, things like that, are millions or even billions of years old. We hear that. You see that on almost every TV program. You turn on a certain kind of science channel or program, and they're immediately going to say, and millions and billions of years ago, they assume immediately that it's that old. Okay? They say that. You'll see it almost every time. So you say, well, how's that determined? How do they determine that? How do they know? Okay, so today we're going to talk about the dating methods and techniques in part, not the whole thing, but part of it. So we're going to look at how they, and I use that term loosely, the experts, determine how old the Earth is, and of course the flaws. We're going to point those out because there's many of them. And the so-called experts who claim that these things are billions of years old, the Earth and strata, fossils, things like that. On one end you have young Earth creationists who say the Earth is only several thousand years old. Okay? And then on the other end you have evolutionists who say, no, it's millions or billions of years old. Okay? The important question is, what does reliable evidence show? So we always want to look at evidence, and that's what apologetics helps us do. Look at evidence, not assumptions, not deceptions. What is reliable evidence in these things? So fossils and rocks make up the bulk of material that experts examine and use to measure, okay? These time measurements. There's three primary methods used for dating. There's other methods as well, but three primary ones. And we'll even look at a fourth method on top of that. Just, we can't go into too many of them because of time's sake. Look at the three major ones. That's geological strata dating, we're going to talk about, radiocarbon dating, and radiometric dating. And of course, there's variations of each of those. Geological strata dating is probably the most common used for this, for dating fossils, and probably the most simple to use. Pretty easy to understand. Number one, they date fossils based upon the ages of the geologic strata. Anybody know what the geologic strata is? Yeah, sedimentary layers, very good. And you can also share with people. So the layers that you see, the sedimentary layers of soil, okay, or soil, rock or soil, that's what they call the geologic strata. And then you find fossils that are found in them, okay? But it begs the question, so how do we determine the ages of geological strata or the layer of that sedimentary rock or soil that we see? How do we determine that? And then two, what the experts do for dating the geological strata is to use the ages of the fossils that are found within them. So from number one that I mentioned to number two, did anybody hear something strange in that?
They use the rocks to date fossils.
Say it louder, Reagan.
They use the rocks to date the fossils and the fossils to date the rocks.
Yeah, they use the rocks to date the fossils and the fossils to date the rocks. That's exactly right. What's that called? Circular reasoning. Very good, Austin. Good job. We'll run out of candy today.
Yes.
Okay. So they use circular reasoning. So that's a huge fallacy that we have to reject. Okay, the ages of the fossils are used to date the strata. Then we can't reliably use the strata to date the fossils. That's crazy talk. Okay, let me just say that's crazy. Okay, circular reasoning methods are unreliable and they should be rejected. The second, probably most famous method for dating is called radiocarbon dating, also known as what? Anybody know another name for radiocarbon dating?
Carbon dating.
Carbon dating. Who said that over here? Who said that over here? I give it. Gil's got to, so Ricky can have it. So how this works, okay? Radioactive carbon is absorbed by living organisms throughout their lives. They absorb it, okay? So plants absorb this. Animals absorb this, or they eat plants that absorb radioactive carbon. We have some in our bodies, just due to eating animals or plants. We have some radioactive carbon in our bodies. And then when something dies, the absorption stops, okay? And then the radiocarbon begins to break down to another form of carbon, okay? So that's the first process. Because this breakdown occurs at a presumed constant rate, there's an assumption, a presumed rate, it's theoretically, keyword there, theoretically possible to compare the amount that has broken down, the broken down carbon, to the amount of remaining radioactive carbon and estimate how long an organism's been dead. In other words, how much is still there, how much is decayed, and then compare the two. That's, in short and simple, that's how they do that, okay? One huge problem with this theory, huge problem. The radioactive carbon has an expected life of less than 62,000 years. Does anybody see an issue with that?
Because they were older.
That's right. How can anything be older than that? So how can things be millions of years old when the maximum for this is 62,000 years expected life? So anybody suggesting that something is millions of years old by using carbon dating methods are either lying or they're ignorant about the scientific reality. Okay, that's the first thing. But that's not all. First, the ratio of carbon and radioactive carbon is not known because there were no observations of it in the death of the organism. Okay, no observations. No one was there to see and determine. So in other words, they are assuming what the ratio is. They're making a blind assumption. What did we say? What did we say on and on and on repeatedly about this? Assumptions and deceptions. Watch for them in evolution. Both of these carbons are formed at rates that can change dramatically over time and with different conditions that are out there in the world. The rate of formation and breakdown could change substantially from ancient times, where this was happening, to today. So it's not uncommon at all. Third, the possibilities of contamination could certainly happen and is very likely to happen over time. The older the sample, the higher the probability there's going to be some contamination, and it will be unreliable. So an unreliability there. Let's use a swimmer as an example. So let's kind of illustrate this. Is knowing the start time of a race, say a swimmer is swimming the 1,500 meters. Knowing the start time of the race, is that enough? Just saying, I know when that race is going to start. Is that enough to know how fast that swimmer swam and who won? No. What else do you got to have? You got to wait to have a stopwatch. Okay, so picture the Olympics. Okay, view the Olympics in your mind, and view somebody swimming 1,500 meters. Think about what all you're seeing in that race. First, you have to have a stopwatch that is properly calibrated. That's the first thing. What else you got to have?
A pool.
We'll assume that.
Assumption of assumption.
That's right. Very good, very good. What else do you have to have? That's a good point. Anything else? You have to have swimmers. What else as far as knowing the proper time?
Someone to start and stop the
Someone to start and stop the stopwatch. What else?
An end time.
Huh?
An end time.
An end time that goes along with the stopwatch. What about observers? Have you ever seen the Olympics and every time they come down they look straight down to make sure they're touching the wall? Well, what happens if somebody swam halfway and said, oh, I think that's pretty good, I'm just going to go, and take the lead? No, that's not going to work. They have people that are watching, and every lane they're watching. They have 2 or 3 observers along with the stopwatch and everything else. So they're very precise, okay? Without observations, you can't be sure that the time is valid. You can't be sure, okay? So hopefully that illustration helps. This is why you need at least 2 and sometimes more observers throughout the entire race to measure it, to make sure it matches the standards that they need. Okay? Why would we believe that dating fossils, ancient fossils, or even the Earth isn't in need of similar observations? Why would we think that? Why would we think that just knowing when something died is all we need to know? So information gleaned from a technique that is limited to 62,000 years depends on unobserved carbon ratios over time, is unreliable for dating fossils, much less the Earth, right? I'm going to give you some examples. There are many flawed methods out there, many examples of how this is flawed. Let me give you just a few. I'll give you one from a couple of different decades. In 1963, living mollusk shells were dated as being 2,300 years old. They were still alive. Okay. 1971, a freshly killed seal had just been killed, was carbon dating as having died 1,300 years ago. He had just died. So that seems a little odd to me. You're talking about flawed. In 1984, shells from living snails were carbon dating as being 27,000 years old. You think a snail moves slow today? Just imagine if he was 27,000 years old. He's going to move really slow. 1996, a geologist at Berkeley Geochronology Center, Carl Swisher, used the most advanced techniques. Okay, at the time, these were the most advanced techniques, and he was using them to date human fossils. While reevaluating Homo erectus skulls found in Java, he tested the sediment that was found in them. Okay, these species was thought to have vanished 250,000 years ago, so he said, and had dated. But even after using the most advanced techniques that Swisher used, these different dating methods, 2 different types of techniques, he kept having us this startling find that didn't match. Okay, one, he said the bones were 5,300 years old, 53,000 years old at most, and possibly no more than 27,000 years old. Well, that's a huge difference. But compare that to 250,000 years old. That's a 96% error. But they use these methods all the time and say, oh yeah, we use this method and this is how old it is. Well, no, there's some issues with those things, all right? So many more examples. Let me show you a couple of books. If you don't have this book and you're interested in evolution, it's called The Evolution Cruncher. It is filled with things that I just gave you. In fact, 928 pages full of facts about how evolution is wrong. I mean, facts, things they've dated like I've just given you, and more examples that I'll give you. I mean, we could sit here and read this for days, and you would just be dumbfounded by some of the things that are in here, okay? So if you're interested, good book. Another one is called Refuting Evolution. You probably actually saw this when Gary Bates was here. Remember that several months ago? Well, this is his older edition. He's got a newer one now that he had with him. This is an older one, okay, called Refuting Evolution. Good book, if you're interested. It kind of tells a little bit more of the overall, what we've been talking about, where Evolution Cruncher gives you more of the numbers that we've been talking about, okay? So 2 great books for reference if you're interested in getting more into evolution and checking it out in those regards. So the third method is called radiometric dating. It's a technique used to age materials like rocks. It's usually based, kind of similar to what we just talked about, based in comparison to the original amounts of radioactive isotopes, okay? Assumed, there's the word, to be in a rock, okay? It's also known as a parent atom. To the amount of the byproduct, the final byproduct that is produced when the isotope decays, known as the daughter atom. Sort of like what we just described, okay? Carbon dating, what was it at the beginning compared to, after the decayed amount at the end, okay? Again, reoccurring theme, false assumptions, okay? Assumed. This has even more issues than carbon dating did, like if it didn't have enough problems. This one is even worse. We don't know the quantity of daughter atoms when the rock was first formed. Again, big assumption. We don't know whether radioactive decay is the only thing that altered this, the parent or the daughter atoms, over time. We don't know whether the decay rate has always been constant. This method is also very unreliable. I kind of sound like a broken record. Do you hear that? We don't know. We don't know. Assumptions. We don't know. That's what you're going to get with these things. Or, they'll try to say that they know, but this is what they get, and we've shown it. Okay, let's look at some examples using the isotope potassium argon. Some more examples. It's been used to date the Sunset Crater near Flagstaff, Arizona, at 200,000 years, but we know it's less than 1,000 years old. We know. Okay, not an assumption. It's been used to date Mount Negora lava flows at 275,000 years old, but we know they're less than 100 years old. Hawaii lava flows have been dated up to 22 million years old, but we know they're less than 300 years old. How long ago was 1971? 42 years. Who's on first? Sheriff, you want to, or you want to? I'll give you a different kind. Let me know which kind you like or want. I'll give you a different kind. Right, 42 years, okay? 42 years is when this erupted. 42 years ago, but they dated it at 350,000 years old. So it's kind of weird. Again, okay, another one for somebody else since you're in math. 1980. How long ago was that? 33 years ago. So that's when Mount St. Helens erupted. Okay, but they dated it at 300,000 years ago. And this actually was before you were born, but certainly well after I was born. So I remember that happening. But it was dated at 300,000 years old. Okay? These are just some of the flaws that we're talking about using isotopes as well. Fourth method, also known as ice core drilling. Has anybody ever heard of that? Ice core drilling. Okay, I'm going to show you some slides on this because it's kind of interesting. So let's see if I can get slide one. You see that? Ice core drilling. All right, so the U.S. National Ice Core Laboratory has ice cores that are drilled. They do this in the North and South Poles, both ways. And they're supposed to be able to tell you how old the ice is by the rings, kind of like a tree. Have you ever seen a tree cut and you see the ring? They say, well, that represents how old the tree is, okay? And they say each ring is supposed to mean a year. Let me continue on with this. So there's a ring. And just to draw some lines on there, you see kind of the draw lines to help represent what the rings are supposed to be, okay? So this ice core machine drills down and can piece these pieces of cores together, even going down 10,000 feet. So they don't drill 10,000 feet. They might drill 100, but they can piece it together down to 10,000 feet. So drawing some lines on the pictures, you see what the rings represent, or what they show here, okay? Supposedly, these lines represent summer, then winter, summer, then winter. So what's the assumption? Anybody know what the assumption is there? Huh?
It only snows once a year.
It only snows once a year. These are supposed to be annual or yearly, okay? These rings are supposed to represent annual rings, okay? Big assumption. But there's a very, very interesting and true story, okay? There was these pilots called the Lost Squadron. Let me get these pictures up because this is a really cool story. So this is the path that the Lost Squadron traveled, and they were really lost. And they eventually landed in Greenland, okay? And there's a picture of the Lost Squadron. These planes are from World War II, okay? So during World War II, they ran out of gas. And they found a spot to land. It just happened to be Greenland, okay? Long story, but they landed, were okay, kind of crashed a little bit, but the planes were pretty much okay. Couldn't use the planes any longer. But they were rescued. They left the planes. This rich guy from Kentucky, 48 years later, he decided, you know what? This would be pretty cool to go excavate these planes. I mean, they can't be very deep. It's just 48 years ago. We'll just go up there, brush off a little snow, gas them up, maybe fix them if we need to, and fly them out. It'd be pretty cool for, you know, some kind of museum somewhere. And so that's what he decided to try to do. But what he discovered was he had used ground-penetrating radar just to find them because they were so deep. And so much ice had accumulated over them, they were 263 feet deep in just 48 years. So let's get a couple more pictures up here. So that's the ground-penetrating radar that they had to use just to find them. And that is an article that kind of talks about how far down they were. Okay? So, and they found a way to get them out. And but do the math. So the planes were there 48 years, okay? But according to ice core drilling dating techniques, these planes were supposed to be there 1,824 years, according to their techniques for ice core drilling. Okay? And the newspaper said this was supposed to represent 135,000 years per 10,000 feet if it were down that far. And the excavator said just in that 48-year time frame, there were many hundreds of these rings, many hundreds of the rings that we showed you a couple of slides ago. Okay? By the way, these are called barbs. So you ever seen in your textbook a word called barbs? That's what they're referring to. These ice core drilling techniques and rings. So the rings aren't annual. What are they? Hot to cold. Very good. Hot to cold, hot to cold. So it's not yearly, as they pointed out. But some say they sank due to the weight and different things and all that. But it's not true for a variety of reasons we're not going to go into here. But they've proven that that's not the fact. The fact of the matter is that they made some bad assumptions. And it is not yearly, but hot to cold. Let me give you one more. So there's a slide that shows the years and how far it went. And that was, actually that's Grand Canyon, so I'll leave it right there because that'll be the next thing that's coming up. So, again, Evolution Cruncher, that particular example is in the Evolution Cruncher book. A lot of examples in there. I'd recommend getting it if you're interested in those things. All right, the Grand Canyon. It took millions of years to form the Grand Canyon, right? No. They say a slow river carved out the Grand Canyon over billions of years, right? No. What is the name of the river that flows through the Grand Canyon? Everybody knows that. Maybe one or two. That makes it so great. All right, so the Colorado River enters the canyon at 2,800 feet elevation, and it runs downhill. By the way, rivers flow downhill. That's kind of what they do. But there's what's called the Khabib uplift in the Grand Canyon, okay? But this slopes up to the top of the Grand Canyon at 6,900 to about 8,500 feet in elevation, okay? So the top is higher than the bottom by over 1 mile. And the river runs through the bottom. And I'll show you some slides that help illustrate this a little better. The Grand Canyon was not carved by the Colorado River over billions of years. It was washed out by probably the flood. Imagine that. And we have examples to show that and illustrate that. Okay? So let's look at a couple of slides. So this is what they're talking about. Here's the Colorado River running that way. This is the start of it. We'll see how that elevation goes up. If that had been washed out by a slow, gradual process, there's no way that Khabib uplift could be up that high. It's literally impossible. The fact that it's there suggests that either a dam erupted and a gush of water went down through there, or else a flood happened, or maybe a conjunction of the two. So it did not happen from a slow river flowing through it over billions of years. And the Khabib uplift is definite proof of that. That kind of shows it again, just where the river flows, and that's where it starts, and the elevation is 6,900 feet compared to 2,800 feet at the start of it, or 2,600 feet. So there's that. Grand Canyon was probably washed out in the Khabib uplift area as a result from the flood, not the Colorado River over millions of years. There's no way evolutionists can get around the Khabib uplift. So knowing these techniques, being greatly thought of, that's not enough for you. We're going to give some evidences for a young Earth. So we're going to show some of those, and even that these flawed dating methods they cannot answer. There's no way they can answer. So I gave many evidences for a young creation last quarter, a young creation like the universe. Many evidences for those. But we're going to talk about a few for the young Earth, okay? A few evidences for that. I'll give you one from Young Universe that we talked about last quarter, just to kind of hopefully refresh your memory, because you probably have forgotten a lot of them. But I'll give you one, then we'll get into young Earth, okay? So galaxies wind themselves up too fast. The stars in our galaxy make, what's our galaxy make? Milky Way, very good. No no Milky Way for that. Yeah, you know what? You got that. Milky Way for the Milky Way. So it rotates, right, in the galactic center. So there's different speeds. The inner rotation is a little faster than the outer ones, okay? And the observed rotation speeds are so fast that if our galaxy, the Milky Way, were just more than a few 100 million years old, it would be a featureless disk instead of its present spiral shape. So it could not be 17 billion years old, otherwise our Milky Way wouldn't be the Milky Way that we see. Okay? This goes, our galaxy is supposed to be 10 billion years old, by the way, not the whole universe. It's like 17, just our Milky Way. They say it's supposed to be that way. Evolutionists call this the winding up dilemma. And they've known about it for a long time. And they've tried to have some answers for that, but every one of them failed. Every single one of their answers for the winding up dilemma failed. And this is true for other galaxies as well, so it's not just ours. There's no way that it could be. So for the Earth, that's just one example. For the Earth, there's not enough mud on the seafloor. There's not enough mud on the seafloor. Anybody know that there was mud on the seafloor? Well, there is, okay? Each year, wind, water, winds, things like that, erode about 25 billion tons of dirt and rock from the different continents, different things like that, and then it deposits them in the ocean. The material accumulates, kind of like loose sediment, mud, on the ocean floor. The average depth of all the mud in the whole ocean, including the continental shelves, is about 400 meters. Okay, remember that. They know that. They can measure that. It's about 400 meters. The main way known to remove some of the mud from the ocean floor is plate tectonic subduction. Anybody know what that is? It's kind of what generates earthquakes. I mean, it's whenever the shelf goes underneath the other one. It happens really slowly. And whenever it kind of jerks, that's when you get an earthquake. Okay? But that's how it kind of takes away some of the mud. Okay? So the seafloor slides slowly. It's a real slow process. Beneath the continents, taking some of that sediment, some of that mud with it. According to secular scientific literature, not Christian, secular scientific literature, that process removes about 1 billion tons per year. And as far as anybody knows, the other 24 billion tons that accumulates does just that. It just simply accumulates, doesn't get rid of it. At that rate, erosion would deposit the present amount of sediment in less than 12 million years. But according to evolutionist theory, erosion and plate subduction have been going on as long as the oceans have been around, supposedly about 3 billion years, according to evolutionist theory. If that were so, if that were really true, we would have mud that would be dozens of kilometers deep. A kilometer is almost a mile. Dozens of kilometers, not 400 meters. So there's no way they can explain it, except for a creationist explanation. That is, well, there was a flood about 4,000, 5,000 years ago, and it deposited its present amount, and it matches it perfectly with the amount they find out there right now. So the flood answers it really, really well, and nobody else can. The evolutionist theories cannot. Not enough sodium in the sea. Every year, river, other sources, things like that, dump over 450 million tons of sodium into the ocean. Anybody know how this occurs? Nobody knows how this occurs.
That's the question, I guess.
So you weren't listening, is that what you're doing?
I was.
That's all right. So how does sodium, 450 million tons of sodium, get into the ocean every year? How does that happen? Huh? Well, erosion.
Precipitation.
Huh?
Precipitation.
Precipitation, sure. It rains, it evaporates, rains, and it washes back into the oceans eventually. Whether it be in the rivers, which all flow eventually into the ocean, okay? By the way, it's important to know this when discussing the flood. What I'm talking about is fresh water versus salt water. Okay, so this is pretty key for the flood as well. Only 27% of the sodium manages to get back out to the sea each year. But basically it rains, washes sediment and things out to the sea. As far as anybody knows, the remainder just accumulates in the ocean. If the sea had no sodium at all to start with, if it had zero, and I'm not saying that it did, I'm just saying if it did, it would have accumulated its present amount in less than 42 million years at today's input and output ratios. That's much, much less than evolutionary scenarios of the age being 3 billion years old. A whole lot less, okay? Again, false assumptions. More accurate calculations that come out, even giving generous scenarios for evolution, still give it a maximum age of 62 million years, way less than 3 billion. And that's calculations for their estimates, not stuff that creationists come up. By the way, the many other sea water elements as well as sodium, the amounts that are in the ocean today match the flood perfectly. Perfectly, okay? So keep that in mind. The Earth's magnetic field is decaying too fast. What's the magnetic field do for us? Anybody know?
Waves.
Huh? But what does it do?
It protects us from UV rays.
Protects us, right, from a lot of things, but radiation is probably the biggest thing. Good job, Ricky. Evolutionary theories about the magnetic field are very complex and inadequate. Very complex. A much better creationist theory exists. It's straightforward. It's based on sound physics. It explains many features of the field, many features that match paleomagnetic, historic, and present data. It matches, and it could not be less than 10,000 years old. Okay, those are just a few. Radiopolonium. Anybody ever heard of radiopolonium halos? No. Okay. So, was the Earth ever hot molten mass?
No.
Huh?
No.
Let me read this. Textbooks will say, as the Earth formed, its surface was similar to that of the Moon. But unlike the Moon, Earth's surface was hot with pools of bubbling lava. Okay, so what do you say? Huh? All right, let me read Genesis 1:2. And the Spirit of God moved upon the face of the waters. Now what do you say? It wasn't hot bubbling at all. So Robert Gentry did massive research on this, and he discovered granites all over the world. What's granite? Hard rock, yeah. And he found these little tiny rings in them. And the best analogy I can give you is like if a hand grenade exploded in Jell-O. Okay, that's about the best I can do with that. And these little fragments stuck in Jell-O, a real weak grenade, okay, or else really strong Jell-O. And these little fragments stuck in the Jell-O. They gotta go a certain distance. So as the polonium decays, it's radioactive, and it gives off a little particle, and they go certain distances. Okay, similar to a hand grenade, you end up with a ring of these little particles that go a certain distance. So picture if you had fireworks and it goes up and shoots, and poof, you have the ring, and eventually that's kind of the idea. Okay, if this happens in hot molten rock, it would make this halo, and then it would melt and disappear because it's hot and it's molten. Okay, keep that in mind. Very hot. These have very short half-lives, the polonium. And if it were in hot rocks, it would melt. But if it were not in hot rock, it would leave this ring behind that we're talking about, polonium halo rings. And they're found in rocks all over the world. So Gentry learned these rocks were never hot because you can see these rings. And the polonium isn't a daughter atom. It's not the product of something else. It's original. So it was never hot. You can look that up on halos.com if you want to check those out a little bit more, because it's very fascinating. Another evidence, Earth's slowing rotation, called the Coriolis effect. It's in direct proportional speed to the Earth's spin, how fast it's spinning. Well, the winds from this cause deserts like the Sahara to go through what's called desertification, okay? Which means the desert is expanding. Did anybody know the deserts expand? And they don't stay the same, they've been expanding. And the calculations would show for one of the largest deserts in the world, the Sahara, would have been expanding for about 4,000 years ago. 4,000 years. So what happened about 4,000 years ago? Anybody know? The flood. Okay. So there was no Sahara, and then the flood, and then desertification, and it's dated at about 4,000 years ago. So desertification. Also, along the same lines, barrier reef. The oldest barrier reef was about 4,200 years ago. Another flood evidence. Imagine that. Just a few. There's so many. It's unbelievable of how many things are there that refute evolution. Again, Evolution Cruncher is filled with these types of statistics. Things that evolution, there's no way they can explain, like everything I've just mentioned. Do you ever think evolutionists ever wondered what came first, male or female? Do you think they ever thought about that a little bit? Maybe even once? So for evolution to be true, we're pretty amazing. Our bodies and the differences between males and females are pretty amazing. They're pretty complex, radically different, but complementary, okay? Reproductive systems of male and female, they must have completely and independently evolved at the same stage, about the same time and place. Just a slight mistake, incompleteness in either one of them would make both useless, and the organism would be extinct. Okay, so it's not asexual like evolution would say. That's where a cell is just split in two and they divide, but rather sexual. We're sexual organisms, so they can't explain that. There's no explanation that evolution can give for that at all. They're just dumbfounded by that. Several other reasons that go along with this, along the same lines. Things like fertilizing eggs or pollen. I mean, if you just look through nature, you see it over and over and over again, things that evolution cannot explain at all. Evolutionary, again, this predicts nature would be asexual rather than sexual reproduction. how can you explain the diversity of our sexual diversity? How did it arise or even survive? Evolution cannot explain it. Same thing with the immune system. How could the immune system of animals and plants evolve? It's impossible. Each immune system can recognize invading bacteria, viruses, and toxins. Each system can mobilize the best defenders to go out, seek, and destroy these invaders. Each has memory, and it learns from every attack. It has to be pre-programmed ahead of time. It has to be when when things first appear on the earth. If not, everything would have died. There's no way. So we have a lot. I have a lot more illustrations here, which obviously we are out of time. Again, check out the book Evolution Country and Refuting Evolution. It's filled with these things. I can just go on and on and on and on talking about these different examples. Okay. Next week, we're going to talk about DNA and genetics, the cell. You may have heard terms like mutations versus adaptions. We're going to look at the two different ones. We hit on that briefly in week 1, but we'll go into it just a little bit deeper next week. And then week 5, we'll be talking about aliens, okay? Probably the next 2 weeks are the 2 most exciting weeks to talk about, and for me anyway, so hopefully it would be for you as well, right? The 2 most interesting to discuss. So hopefully you'll be back for the last 2 weeks.